Hello students, welcome to Dr. Sourav's classes. So in this, as you know that we are solving this UPSC Maths optional paper, and this is of paper 1, and we are solving the paper of 2021. Okay, so in the previous video you will find the question solved up to this question number 7. So this is the last question of this paper 1 in the section B. So this is the question number 8. So this Maths optional is a scoring optional. If you have your preparation well, and in particular in UPSC, the thing is that you have to solve every problem, you cannot miss any one. So here I am just showing you the way how to make your answer in the particular exam, and for that, to develop that, you need a lot of practice. Okay, so let's see this question number 8a, and this part 1 what you have to find. So we have to find the orthogonal trajectories of the family of confocal conics x square by a square plus alpha plus y square by b square plus alpha equal to 1, where a is greater than b greater than 0 are constants and lambda is a parameter. So show that the given family of curves is self-orthogonal. Okay. Now we have to solve this. So we have what is given: x square by a square plus lambda plus y square by b square plus lambda is given. So that is equal to 1. Let us take this as equation 1. If we differentiate 1, it will be 2x by a square plus lambda plus 2y by b square by lambda dy dx, right? So it is equal to 0. It is a constant, so it will be equal to 0. Now we can write this as x by a square plus lambda plus y by b square plus lambda dy dx is equal to 0, right? Now if we arrange this, it is nothing but x of b square plus lambda plus y of a square plus lambda equal to, that is, it be dy dx, this is equal to 0. Now if you rearrange the lambda on one side, so it will be lambda of x plus y dy dx, which is equal to minus of b square x, right? So a lambda of x plus y dy dx, it is on the left hand side, so it will be minus of b square x plus a square y dy dx. Now we keep lambda on the one side and everything on the other side, so it will be lambda is equal to minus of b square x plus a square y dy dx, right? So this is by this x plus y dy dx. So if we add a square on both sides, right? So what it will do? So a square plus lambda, this is a square minus b square x plus a square y dy dx by x plus y dy dx, right? So from here, if you solve this, it will be simply a square minus b square x by x plus y dy dx, right? And similarly, if we add b square onto this equation, so it will be simply b square plus lambda, it will be b square minus of b square x plus a square y dy dx by, so it will be, this is this x plus y dy dx. So from here we can find, so it will be equal to simply minus of a square minus b square y of dy dx by x plus y dy dx, right? Now putting this above value, this a square plus lambda and b square plus lambda in equation 1, so in this equation we will put the value. Okay, now what it will be, so putting the value, we will have this x square x plus y dy dx by a square minus b square x minus of y square x plus y, it is dy dx by a square minus b square y of dy dx. This is equal to 1. Okay, so this is equal to 1, right? So simplifying this, we will get, so it will be x plus y dy dx multiplied by x minus y dy dx. This is equal to a square minus b square. So we are giving this equation name as equation 2, right? Now this is the differential equation of the family, this equation, differential equation of the family, that is 1, that is from the equation 1. Okay, now replacing this dy dx by minus of dx dy, the differential equation of the required orthogonal trajectories will be, so here we have this x of plus y minus dy dx, this is multiplied by x minus y minus of dy dx, this is equal to a square minus b square, or we can write it simply as x plus y dy dx, and here it is x minus y dy dx. Okay, so I have this, it is, we have taken that, what we have taken, that is dy dx is equal to minus of dx dy. Okay, so it will be, this will be all dx dy. This will be also dx dy. So now this is equal to a square minus b square, right? So it will be equation 3. Let us take this equation 3, so which is the same as the differential equation 2, that is same as equation 2, right? of the given family of the curves, and this equation 2 is, so these are the all the differential equation for the given family of curves represented by equation 1. Okay, hence the system of the given curves is self orthogonal, that is each member of the so from here you can see that equation 3 is same as equation 2, and they are all belong to this given family of the curves that is represented by equation 1. So that is their self orthogonal, and each member of the given curves, this each member of the given family of the curves intersect its own members orthogonally. Okay, so that is the answer for this question 8a part 1. So we have find the orthogonal trajectories, and that the given family of curves is self orthogonal. With that we have also proved, right? So in the next video we will solve this part of 8a2, that is 8a of part 2. See you in the next video.